Here we have some basic properties of addition, multiplication, and the distributive rule that we're going to cover. So, first of all, let's take a look at what's called the commutative rule for addition. That simply states that A plus B is the same as B plus A, so you can flip them around, of course. 2 plus 5 is the same as 5 plus 2. That's called the commutative property when you flip them around like that. You have an associative property for addition, so that states that A plus B added together first plus C is the same as adding B and C together first and then adding A. That's what the parentheses mean. You add what's inside the parentheses first. So for example, 2 plus 3 plus 5 is the same as 2 plus 3 plus 5, where the left-hand side means you add the 2 and 3 together first, so you have 5 plus 5, and of course that's 10. And on the right-hand side, you add the 3 and 5 together first, so you have 2 plus 8. Well, of course that's 10 as well, and you see that these are equal. So in other words, the associative property for addition means you can just move the parentheses anywhere you want, as long as everything is being added. You also have what's called the additive identity. That's the number 0. It's called the additive identity because any number A plus 0 just gives you back A. So of course 3 plus 0 equals 3, for example. You also have what's called the additive inverse of a number. The additive inverse of a number A is negative A, because A plus negative A is 0. It's the same as just A minus A, which is 0. For example, 5 plus negative 5 is the same as 5 minus 5, and that's 0. So that's called our additive inverse of a number, negative that number. We also have some basic properties for multiplication. We also have a commutative and associative property for multiplication. So, of course, A times B is the same as B times A. 2 times 5 is the same as 5 times 2. They're both 10, of course. The associative property for multiplication means you can move the parentheses around, just like for addition. So, for example, 2 times 3 times 5, this means you multiply the 2 and 3 together first. That's the same as if you multiplied the 3 and 5 together first and then multiplied by 2. So for example, on the left-hand side here, 2 times 3 times 5 is 6 times 5, and of course that is 30. Whereas on the right-hand side, you multiply the 3 and 5 together first, so that would be 2 times 15. Well, that's still 30. Same number. So in other words, you could move the parentheses around anywhere you want, as long as everything's being multiplied again. You also have what's called the multiplicative identity. That's the number 1, since any number times 1 gives you back the same number. For example, 3 times 1 is 3, of course. We have the multiplicative inverse for a number. If you're given a number A, the multiplicative inverse is 1 over A, because A times 1 over A gives you back the multiplicative identity, which is 1. For example, the multiplicative inverse of 2 is 1/2, because 2 times 1/2 gives you back 1. Similarly, 2 is the multiplicative inverse for 1/2 as well. So 1/2 is the multiplicative inverse for 2, and 2 is the multiplicative inverse for 1/2. They're both multiplicative inverses of each other. We also have some distributive rules for multiplication and division. So the distributive rule for multiplication goes like this. A times B plus C is the same as or equal to a times b plus a times c. Notice how you distribute the a to the b and to the c. So for example, 2 times 5 plus 3 is the same as 2 times 5 plus 2 times 3. So you distribute the 2 to the 5 and to the 3. Now, just to verify this quickly, the right-hand side would be evaluated like this: 2 times 5 plus 3. Now, by order of operation, which we have to get to, you do what's inside the parenthesis first. So this would be 2 times 8, and that is 16. On the right-hand side, 2 times 5 plus 2 times 3. Well, now you do the multiplication before addition. That's another rule that we will get to under order of operation. So 2 times 5 is 10. 2 times 3, of course, is 6. And when you add them, you get 16, and you see these are the same number. So that illustrates why this is true right up here. So that's called the distributive rule for multiplication. You also have a distributive rule for division, which it's really the same as multiplication. It just looks a little different. It's really the same rule, but it goes like this: a plus b divided by c is the same as a over c plus b over c. So you can think of splitting this fraction apart. For example, 10 plus 4 divided by 2 is the same as 10 over 2 plus 4 over 2. Just to verify that, if we look at the left-hand side, 10 plus 4 divided by 2. Now, we do what's in the numerator first. The top of the fraction is called your numerator. The bottom is called your denominator. So we add 10 and 4 first, and we divide by 2, and of course we get 7. Now if we do the right-hand side here, notice if we split this fraction apart, that's the right-hand side, it would be 10 over 2 plus 4 over 2. Now we do the divisions first because they have a higher order of precedence than the addition, and we'll get to that. So this will be 5 plus 2, and of course that is 7, and you see we get the same thing. So that illustrates our distributive rule for addition. Now take note of one thing here. This is important. While it is true that you can do this with a fraction, that's only if the addition is in the numerator of the fraction. You cannot split the fraction up if the sum is in the denominator. So what I mean there is that if you have something like a over b plus c, this is not equal to, does not equal a over b plus a over c. You cannot do this. This is not correct. And to verify that, we'll just do a simple example here. Just consider this. 5 over 1 plus 4. Well, if you were to evaluate this, that is simply 5 over 5, which of course is 1. But if you were to split the fraction up incorrectly and write it as 5 over 1 plus 5 over 4, well, that is 5. 5 over 1 is 5, and 5 over 4 is 1.25. You can evaluate that on your calculator if you want. And that, of course, is 6.25. Well, of course, these are not equal to each other. So, you see, you can't split a fraction up like that if the addition is in the denominator. So just be careful about that. Let's take a look at a few examples. So let's verify the distributive property for multiplication for this quantity. So we'll simply evaluate 3 times 4 plus 7 like this as it sits. So we'll add the 4 and 7 together first because they're inside the parentheses. So this would be 3 times 11, and of course that is 33. If you distribute the 3 to the 4 and the 7, you would get and this is going to be 12 plus 21, and of course that is 33, and we see that these are equal to each other. So that verifies the distributive property for multiplication in this case. Let's take a look at this one. Let's verify the distributive property for division for this quantity by doing the same thing. So if we evaluate now, what we'll do is we'll add the 2 numbers in the numerator first, and we get 35, and that is 7. Now if we were to split this fraction apart as notice we would get 3 plus 4, which is still 7. So we get the same thing, of course. So that verifies the distributive property for division. Now let's take note of something important here if we were to try to evaluate this on a calculator. If you evaluate this on a calculator, you must put what is in the numerator in parentheses. So you must enter it like this if you type it into a calculator. So in a calculator, you must enter it as like that. Let's just try that quickly and see that we get back 7. So I'm going to pull up now I have a virtual TI-83 here. Now if we enter parenthesis 15 plus 20, and you can follow along here, close that off, close the parenthesis off, divide by 5, and of course we get back 7. Alright, so that looks good. Now suppose we didn't put the parentheses there. What would happen? Well, let's see. So if we entered it like this, like 15 plus 20 divide by 5, well, let's see what we get and follow along with your calculator. So if we go 15 plus 20 divide by 5, let's see what's going to happen here. We get back 19. Not the right answer. Well, what your calculator is doing here, and we will get to this when we cover order of operation, your calculator has to decide, do I do the plus first or do I do the division first? Which operation do I do first? Well, by the standard rules that we follow, it does multiplication and division first. That's what calculator and computers are designed to do. They do multiplication and division before addition and subtraction. Now actually before even multiplication and division are parentheses and exponents, but we'll get to that. So the point here is that it does division before addition. So it'll do the 20 divided by 5 first and give you back 15 plus 4, and then it will evaluate that as 19. So to force it to do the addition first, what you have to do is put parentheses around the 15 and the 20. That will force the calculator or computer to do the addition before the division. So that's a general rule, and we'll state this again later, but if you're evaluating a fraction, with like an x, say x and a y, where you have two expressions, x and y. And if there's something more complicated than just a single number, if the x and y are something, if they have additions and subtractions in them, if they're more than just a single number, put them in their own parentheses. So evaluate them like this. Okay, you would type it in like that. Now that's only if they're, once again, that's only if they're more complicated than just a single number. Single numbers, you don't need parentheses. All right, and we'll talk about this more when we do order of operation. Why don't you try this one? Use your calculator to evaluate 2 times pi plus 1 divided by 3. Now you have to find the pi button on your calculator. If you're using the TI-83, that's a very common calculator. That's why I use it as a virtual calculator here. The pi button is right above the hat button there. That's the hat. That's the exponent button. So you'd have to press second and then the pi, or the exponent button, and you'll get a pi right there. All right. Try that on your own and see if you can get back. You should get back 2.427728. And then if you want to round it, let's see, the problem here says to round to the 4th decimal place, you should get 2.4277. Now, assuming that you tried that, let's go over it here. So we have to enter this as parenthesis 2 times pi plus 1. Okay, so that's our numerator. We have to have it in parentheses because it's more than just a single number, divided by 3. So let's enter that into our TI-83 here. I have to clear that out first. 2 times pi plus 1 divide by 3, and then we hit enter. And there we go, that's our answer. And then if we want to round that to the 4th decimal place, we would go to the 5th place right here is a 2. And so we would round this just as, we would just say that this is approximately 2.4277. And that's rounded to the 4th decimal place because the 2, the 1 in the 5th, is less than or equal to 4. Right, and that's our answer. Now let's try doing this in Excel, because we can do all of these mathematical expressions in Excel as well, and it's good to get some practice using that. So bring up Excel on your, you can pause here and bring up Excel. So here I have Excel. Now we're going to enter this expression into Excel just like we did here. Now the only thing with Excel is when you enter an expression, you have to put equals in front. That tells Excel that's what's following is supposed to be evaluated as a mathematical expression. So let's type in equals parenthesis 2 times, you have to use the times symbol. You must use the times symbol in Excel. Pi. Now pi, yeah, how do we evaluate pi in Excel? You type it in like this. There is no pi button on your keyboard, so you have to type it in like this. That's how you type in pi. Pi, and then just parentheses, plus 1, close it off, divide by 3. Then hit enter. And there you go. That's the same value that we got on our calculator. Alright, now that pi, I typed it in as uppercase. You could type it in as lowercase, pi like that. Still evaluates it out. In fact, it made it uppercase. Alright. And this note down here is just reminding us that we have to use the equal sign when we type in mathematical expressions in Excel, and you must use the asterisk when you type it into Excel. In the TI-83, you don't technically need that times symbol there since pi is a built-in constant in the calculator, but I still recommend doing it. I mean, you could type it in as okay, but I still recommend using the times symbol in between because some calculators will require it. So it's just good practice.